Right, let's look at solving equations for a while, okay? Here is an expression, 35u plus 60. This is an algebraic expression. And it could be something that would be, say, U could stand for units of electricity. And you could be paying 35 pence per unit for your electricity. But then there's some sort of standing charge that you always add to the bill of £6. So I put 600 because that would then be in 600 pence. So same unit of currency. So that would be an expression to say I've used up 35 units of electricity and I'm going to add on the standing charge, this plus 600. It's an expression because there's no solution to it. There's no equals in there. There's nothing I can do to find out what u is. But if I were then to say this equals 45, in fact 45 because I'm in the same unit. So in other words, my bill came to £45. I now have an equation that I can solve to try and find out, well, how many units of electricity did I use? Okay? And then I can go to the meter, read off how many units of electricity I actually used, and then query the bill maybe if I don't agree with it. So I've gone from an expression which describes how you work out the cost of your electricity. You multiply however many units you've used by 35p a unit and add this standing charge. Now I've added to that the cost of a bill, which is 4,500 pence, £45. So now I can say, right, let's work out how many units. Yeah, I've got an equation to solve. How I solve it is in exactly the same way as you would rearrange a formula. Whatever I do to one side, I must do to the other. So if I'm going to add something to the left-hand side, I must also add it to the right-hand side to keep the equation balanced, and this equals means it's balanced. If I subtract something from one side, I must subtract from the other, and so on. Divide, multiply, square, whatever operation I do to one side, do to the other. And the point now is I'm going to try and get u on its own. An equation differs from a formula in that, well, sometimes it works in formulae too, but you might have the unknown appearing more than once, and then you've got an equation to try and solve where the unknown appears more than once, so they get a bit more complex. We'll have to look at examples like that. So let's try and solve this equation. What would you do to this equation first to try and get u on its own to end up with u? Take 600 away from both sides, delete, get rid of this 600 here. So if I subtract 600 from the left, I also subtract 600 from the right, and I have that 35u equals 3,900. And then, yeah, divide both sides by 35. So u equals 3,900 divided by 35, and I've solved that equation. Whatever I do to one side, I must do to the other. BIDMAS, anybody heard of BIDMAS or BODMAS, whatever you call it? What is that? Multiply, add, subtract. Exactly. Order of operations. When you're trying to solve equations, and the equation, one side of the equation, look, involves addition and multiplication, you actually undo it in reverse, the other way along the BIDMAS route. So you get rid of adds and subtracts, generally, not always, before you get rid of multiplies and divides. It's hard. It's always dangerous to go up with a hard and fast rule, because some equations ask for other routes to solve them. And at the end of the day, the only way is to just do loads, which is what I'm going to ask you to do. Okay? So if I've got addition in there and multiplication, try and get rid of the addition first, which is what we've done, and then the multiplication. Here's another problem. Here's a trapezium. Side A, side B, perpendicular height h, so that's a right angle in the corner there. The area turns out to be a half A plus B times the height. Given some values for the perpendicular height of this trapezium, as 3.6 centimetres, the length of the base B is 6.2 centimetres, and the total area is 16.4 square centimetres. We've got to work out what A is, find A. Side A. Let's look at this. This right-hand side of this formula here is an expression to find the area of a trapezium. That's an algebraic way of writing what you do to find the area of that trapezium. Now let's just think about this for a minute. If I look at this trapezium, actually, if I wasn't given that formula, I wanted to work out what the area of this was, what I do is I imagine it's a rectangle, because I know how to find the area of a rectangle with height h and two equal sides. The question is, what must be the length of these two equal sides? These two sides, A and B, which by the way are parallel to each other, so we should really put little arrows on them. That's what makes it a trapezium. These two sides are parallel. What could we do to find the length of this question mark side here in blue, knowing A and B? If we look at this expression, the half A plus B is actually the average. So this length from here to here is the average length of A and B. What we're doing is we're saying we're going to replace these unknown but different lengths, A and B, by two lengths we do know that are the same. And then we can find the area by just multiplying that average length by the height. How do you find the average? A plus B times a half, or divide by 2. And that's what this expression is telling us here. Find the average length of those two missing sides and then multiply it by the height. This is an expression, algebraically saying just that. You see that? Okay? So what's that going to give me? The area. So in other words, now we call it a formula because it's the area. It's telling us the half A plus B times height. Gives us this area. So if I've got this situation underneath here, and I want to find A, I can either rearrange the formula or I can form an equation and solve it. We've looked a little bit at rearranging formulae, so I want to look at that, and also I want to look at how we'd solve it as an equation. So I'm going to split the board into two, and on one side I'm going to rearrange the formula to solve this problem. And on the other side, I'm going to form and solve an equation, which is really the aim of today. So, the left-hand side, we've got area equals a half A plus B times H. And I want to remember, rearrange for A. I want to get A on its own, that missing side. I have to think about bid mass, but also reversing operations. So I asked myself, what was the last thing that was done to this right-hand side and undo it? So what would we do? Divide both sides by H, we'd get rid of this H. A over H equals a half A plus B. Right, someone else? What might you do next? I'm after A, what's happened to A? What was the last thing that happened? Divided by a half, yes. Or, remember we were talking about finding a half of something is the same as dividing it by. So instead of divided by a half, multiplied by 2. Same thing, okay? So multiply both sides by 2. 2a over h equals a plus b. And now we're virtually there, aren't we? All we've got to do now is subtract the b, and we've got it. So a equals 2a over h minus b. And we've got a formula that will allow us to calculate the length of that missing side. So all we'd have to do now is put in the numbers and we could solve it. Okay? Yes, that's right. To get rid of the half, multiplied by 2. Yeah. The beauty of this way of doing it, as we've seen from last week, is that we could now plot it. And we could actually look at the relationship between the length of this side A and the area, or one of the other sides or something, by letting one of them equal y and the other one equal x and plotting on an autogram. So we could see how the length of that side varies with all these other variables, A, H and B. So that's a very powerful way of doing it, to find out what the formula is or the function is. You all right, Tommy? Now let's try and form and solve an equation. So let's go to the original formula, but now put in the numbers. In other words, an equation like we did on the last example. So a equals 16.4 equals a half a, which we don't know, plus b, which is 6.2, all times by the height, which is, sorry? No, be careful, that's just a unit, square centimetres, yeah. Hang on. The other way to do this then, form the equation. Look, this is what I mean by forming the equation. Plug in what you know. And now we've got the unknown a, so you've got to solve it. And the process is almost the same as for rearranging the formula. As Alfie suggests, divide both sides by 3.6. So if I divide 16.4 by 3.6, I get 4.6. Right, so 4.6 equals a half a plus 6.2. Now what would you do? Nope. Get rid of this half. How do I get rid of that? Times by 2. 2 lots of 4.6 is 9.2 equals a plus 6.2. So now we've got rid of the half, we don't need the bracket anymore. And then you can see that finally you just subtract the 6.2 from both sides and I get a equals 3. But there's some rounding going on here because you rounded there, didn't you? So yeah, to one significant figure or two significant figures maybe. If you plug the numbers into the formula, you should get the same answer. Two ways of doing the same problem. Yep. So on page 62, you'll see this chapter on solving simple equations. This process, there are some work problems that you could look at and see how they've done them. But if we look at one or two, we can see if we look at problem number 7, solve 3x minus 2 equals 9, multiply out the brackets. 3 or divide by 3. You can do it either way. They've actually multiplied out the brackets to get 3x minus 6 equals 9 and then solved it that way. Actually, I probably wouldn't have done that. I'd have divided both sides by 3 to get x minus 2 equals 3, and then you'd have had x equals 5 quicker. So in other words, there's more than one way to solve these things, but look at what they've done in these work problems. If you see how they work, then have a go at some of these. Like exercise 31, solving simple equations, exercise 32, more complex equations, and so on. I'll leave you for a period of time now, and then we'll stop and have a look at a few together that have caused problems. So that chapter and those exercises.